Isomerism. Isomerism. All of us, you know what is the definition of isomerism. So can you tell me the definition of isomerism? Hello. What is isomerism? What is isomerism? No reply. Compounds having same molecular formula but exists. Compounds having same molecular formula but exist in not but. Compounds having same molecular formula with different structures are called isomers. And the phenomenon is called isomerism. Now we'll discuss its classification. Okay. Classification. Okay. Before classification, I'd like to tell you something. See, how can you have different structures? That for that one, I think most of you in your childhood, you have played with some cubes. Say your parents have brought it and you can join one cube with another. So if you join in different places, you can get different structures. Okay. You can make a house, you can make a gate, you can make a pass, and everything is that. Say, look at this, my hand. This is the one. What do you find? In this one, all the 5 fingers are in one direction. Okay. So if I feel that my upper portion is crowded and here no finger is there, See, if I pluck one of them, I can put it here. If I put it here, then my hand will look like this. Okay? So in that case, what is going to happen? Huh? If I take two photographs, the photographs will not be same. What did you do? In this case, one, I have dislocated one finger. I removed one finger and put it in a new place. Okay? That is, the finger which is bonded to this palm, if I dislocate it, form a new location here, then you'll find these two are having different structures. So, in a molecule, atoms are linked with each other through bond. So, if I want to dislocate one atom from its original place, what I have to do? I have to break that bond. Then, in a new place, I have to form a new bond. So, by that way, you can get different structures. And second one is that, say, look at these 5 fingers. Huh? Now, if in that case, if 2 of them are like this, now this photograph is different. See, the structures are different. But in that case, I did not remove my finger. Only thing, what did I do? I have changed the direction of this finger. It was initially 90 degree. I have made it like this. So this is the way I can have different structures. In this case, what did I do? I did not break my finger. I did not remove my finger. Only thing there that I have changed the direction of the finger. So let us start our story. The story starts with molecular formula. So with the molecular formula, how can you have different structures? I already told you the structures, we can have different structures with reference to what? The reference to bonding, connectivity, connectivity. Okay, so if I break it and form a new one, this bonding connectivity is different. And if I do not break the bond and change the direction of the atoms in the space, then bonding connectivity remains same. So if it is different, the isomers are called structural or constitutional. In your book, the constitutional isomer term is not there, but please remember. And in this case, we did not break any bond. So, we call it stereo. Please remember the word stereo means space. Okay? So you have structural isomer. Now, structural isomers again you can classify several categories. One. We call it nuclear or chain isomer. Two. Positional isomers. Three. Functional isomer. 4. Metamers. Okay, in your book only 4 are there, but you should know a little more. 5. Ring chain isomer. 6. Tautomers. জল আইছে অনেক সময় জল এত হলে আমার 10 মিনিট দিবে পানানো জল উঠেছি can be classified into 2. Conformational isomers and called configurational isomers. And these are called, again classified, enantiomers and called diastereomers. This one again I'll tell you later in different. Do one by one. Clear or chain isomer? See here. In the nuclear and chain isomer, you will find the length of the molecule will change. Chain may be either shorter or longer. So let us take the example of this. CH3, say it is this. This is, you know, it is called butane. What will happen? This CH3 group and this H will exchange their position. Okay, so this will come here in this carbon, and as the valency of carbon is 4, if this goes out, valence of carbon becomes 3, 1, 2, 3. So this hydrogen will shift here. See here, what is you are going to get? So this 2 hydrogen plus 1 hydrogen become 3 hydrogen. This. Okay, this CH3 has come here. So I'll write here now CH3 and CH3. See. So both of their molecular formula is same, but the structure is different. See here, this is what we call this one. We call it butane. What is we call it? 1, 2, 3. So this is 2-methyl butane. Okay. All right. So this is the example of the chain isomer. So now I'm just telling you for your entrance exam. Okay. This. The chain isomer of alkanes start with minimum 4 carbon atoms. You remember. Now, this is one example. Suppose I have taken this. Sorry. This. So now this can show you this is pentane. Pentane. Now CH3 can come here. So what will get now here? When if CH3 comes here, then this hydrogen will come here. So it will be, so this CH3 will be now, this CH2 will be CH3 now. See this. So it will become 2-methyl butane. Okay. Now this CH3 can come here. This CH3 from this carbon will come here and this hydrogen will shift here. So what will get now? This. This is 2,2-dimethyl. So these are the example of nuclear or chain isomer. 4 carbon, and here you have 3 carbon. So in chain isomer, the length of the chain will differ. Either it will be shortens or it will become longer. Okay. See, if you do not tell me, then I simply write and drop. Then second is positional isomers. So the positional isomers arises because of the change of the location of the substitution functional group double bond or triple bond. Positional isomers occur due to the change in the location of substitution functional groups carbon-carbon double bond or carbon-carbon triple bond. Okay, so let us see now. Say I have taken here this. So this is 2-methyl pentane. See, same molecular formula. Same number of carbon in the chain. 5 carbon in the chain, 5 carbon in the chain. But it was in this first molecule, it was on the second carbon, and the second molecule, it has gone to the third carbon. Okay, so this is called 3-methyl pentane. All right. Now, this is the change in the position of substitution. So now I have taken here say I have taken this functional group 1, 2, 3, 4, 5. So this is or known as pentan 1-ol. One, two, three, four, five. This is pentan 2-ol. One, two, three, four, five. Pentan 3-ol. Now look at this. Is it also an isomer? Tell me. Because I'm shifting it from right to left now. This is pentan 1-ol, this is pentan 2-ol, this is pentan 3-ol, then this is what? Pentan 4-ol.
So 2.
Yes, so this will not be this. So this is a functional isomer. Now, say I have taken this CH3, CH2, CH2, NH2. Okay, so it is 1, 2, 3. So this is propan 1 amine. So one of the CH3 will goes there. This is we call it N methyl methan amine. I don't have to number it. Okay. These are also functional isomers. Why you know? This is called no, sorry, this is the wrong example. Sorry. Okay. Now this is about substitution, this is about functional group. Now suppose I have taken this CH3, CH2, CH double bond, CH2. This is called 1, 2, 3, 4. But 1 in. Is called but 2 in. Now, similarly, say suppose it is this. One, two, three, four. This is, we call it, please remember, when you have more than one double bond, you have to put a extra A here. So, buta 1,3 diene. Now, so it is called 1, 2, 3, 4. Buta 1,2 diene. our positional isomer. Now, one, two, three, four. This is but one I. This is but two I. 1, 2, 3, 4. When your school is opening?
Sir, Monday.
Achha. Then comes 3. This is called functional isomers. So in this case, what will happen? Molecular formula will be same, but the functional group will be different. Okay. Say we have taken this CH3, CH2, CH2, OH. See, this is alcohol. What is the name here? 1, 2, 3, 4. This we call it butan 1 ol. Then see, this is called ether. Okay. His common name is diethyl ether. Oh, common name. IUPAC name is ethoxy ethane. Okay. Now CH3, CH2, CH2, 1, 2. This is propan 1. CH3, CH2, NH, CH3. This is called N-methyl ethane. So those are both are amine only. Why should I write? No, dear. This is called primary amine, and this is called secondary amine. Okay, it's called secondary amine. So their properties are different. Now, suppose I have taken this What is this? This is an aldehyde. Name is propanol. Okay, 1, 2, 3. Look, all of the molecular formula is same. 3 carbon, 3 carbon. 6, 3 plus 2, 5 plus 1, 6. 6 hydrogen, 1 oxygen, 1 oxygen. But this is not aldehyde, this is ketone. This is called propanol. Okay? Now, say I have taken this. This is carboxylic acid. It's called 1, 2, 3 propanoic acid. See here, 3 carbon, 1, 2, 3, 1, 2, 3. 3 plus 2, 5 plus 1, 6. 6. 2 oxygen, 2 oxygen. We know this is called ester. So this is called methyl gap. Ethanoate. So these are all functional isomers.
তোমার লেপটা একটু রোদে দিয়ে আসো ওরে
Okay, now we'll go for metamers. It occurs with those functional groups which appears within the main chain. That is in between carbon atoms. See, you will find most of the functional group appears at the end. The other side you will not find carbon atoms are there. Only one side carbon atoms are there. But there are some where you find both side carbon atoms are there. So take the example of ether. See, both sides you have carbon atoms. So in this case, you have 2 carbon atoms on the left, 2 on the right. What will happen now here? You will find the number of carbon atom changes on both sides of the functional group. number of carbon atoms changes on both sides of the functional groups. See here, what is the name of this? We call common name. Common name is, see, is called diethyl ether. What is the IPC name? 1, 2. This is we consider substitution. So we call it now ethoxy ethane. What is the common name of this one? This name, this is called propyl, this is called methyl. Alphabetically, M will come before P. So we call this one methyl propyl ether. And what is the IPC name? Is called 1-methoxy propane. Okay, now see here. CH3, CH3, and CH2, CH3. What is the name? N-ethyl ethane amine. See now, here you have 2 carbon, 2 carbon, here 3 carbon, and 1 carbon. So it is what? 1, 2, 3. What is the name now? N-methyl propan 1 amine. One, 2, 3, 4, 5 is called pentan 3-O. See here, this is the functional group. Here, left hand side you have 2 carbon, right hand side you have 2 carbon. Here, this is the functional group. Left hand side you have 1 carbon, right hand side you have 3 carbon. So what is the name now? 1, 2, 3, 4, 5. So it is pentan 2O. See, this is the functional group. Ester. Here you have 3 carbon, you have 1 carbon. This. So it is 1, 2, 3, 4. She is called methyl ester. You know, I have to give a gap. Then 4 carbon. But no double bond or triple bond. So AN ester is called O8. So methyl butanoate. This is called ethyl 1, 2, 3. Ethyl propanate. I am giving you plenty of examples so that you should not face any problem in your school or in entrance exam. In your book. Okay, so I'll give you a little bit more. I don't know whether you like or don't like. Go for 5. It's called ring chain protons. See here. In school, though, you have learned. What is the general formula of alkane? What is the general formula of alkane?
CN.
Yes. CN, then after what?
Plus 2.
CN plus 2. Hey,
H2N plus 2.
again tell.
CN H2N plus 2.
Very good. Then who is that lady initially started with CN, then suddenly kept quiet? Who told me? Najia or what?
Sir, Iba.
Iba. It is CN H twice N plus 2. Good. And what is the formula of alkene? What is the general formula of alkene?
CN H2N.
Yes. And alkyne?
CN H2N minus 2.
Very good boy. Acha, Najia is there in the class. Hello. Remember that CN H twice N, we say it is the formula of alkene. Okay. Now say, let me write C3H6. So with this, what molecule you can expect? We can expect this molecule. Is it not? This is the one. It's propene. Propene. Now, see. We also have a molecule like this. Okay, see, this is alkane. Alkene, this is alkane. This is called cycloalkane. So, what is the name now? Cyclo, how many carbons are there? 3. Does it have any double bond or triple bond? No. Then what should I write here? I have to write this. So their molecular formulas are same or not? The molecular formulas are same. All right? Then what should I say? All the 4 molecules that you have discussed till now, sorry, 4 types we have discussed. We have discussed about structural isomers. We have discussed about, chain isomer. We have discussed about positional isomers. We have discussed about functional isomers. We have discussed about the metamers. It does not belong to any of this class. So this is an example of ring and chain isomer. This is a chain, this is a ring. Interestingly, it is missing in your book. Say I have taken this CH3, CH2, CH2, this. This is but1 Okay. With this, we know it is also possible to get this structure. These are the positional isomers that just now we have discussed. but2. But dear, with this formula, we can also have a cyclic structure. This is called cyclobutane. With this one, I can also have a structure like this. See here. All these molecules exist. These are not ghosts. So what is the name of this? Because only one, I told you in a cyclic compound, you can't say which is the first carbon. If only one is there, we don't put number. So what is the name of this? The name of this is methyl cyclopropane. So these are the examples of ring and chain isomer. Okay. Now I have given you one more. See, please remember, all these isomers that I have written, once they are formed, they do not change their structure. What about the structure we achieve? By the process of formation, they cannot be changed. See, whatever appearance I have got after my birth, normally I cannot change. Of course, one can. So let me show you this. Say, I have taken this. In this case, this molecule also exists in this form. Or suppose I have taken this. This molecule can also exist in this molecule. Okay, I'll draw. Otherwise, you think that it is, I have drawn a window.
ধনিয়া পাতা একটু পরিষ্কার করে রাখবো তো পাতা তো ধনিয়া পাতা দেবো
So these are called tautomers. What should I write now? The phenomenon by which the isomers continuously exchange their structural form is called tautomerism, and they are in dynamic equilibrium. Dynamic equilibrium means what? This continuously occurs. Okay. See now, in this case, what is this? This is a ketone. And what is this? See, you have double bond is called what? ENE. OH group is called what? OL. O is a vowel. So what do you call it now? Okay. So this is the example of keto enol tautomer. And this is the example of what? We call it valence tautomer. This is absolutely for your entrance exam. And those who are not interested for entrance exam, don't write. Have a peaceful life. Another day I'll do the stereoisomer.
Thank you, sir.